Hey guys, welcome to the tutorial for the problem named nested palindromes. So the only part you should be taking away from the problem statement is this: creating all possible palindromes. So even if this problem statement didn't make sense, it is fine, because from the given sample input and output you can easily infer the logic. So here if you take madam, that is a palindrome, and ADA is a palindrome, which gives you a count of 2. Now all the letters distinctly are palindromes, so when you take M, it is a palindrome. That way it has 5 letters, so it gives you a count of 5. So 2 plus 5 is 7. So the same follows for the first test case. In here there are no palindromes in it, but all the letters by themselves are palindromes individually, so that gives you a count of 6. So coming to the solution part, there were some pretty simple solutions that were presented in the contest. This particular solution is from a user with username Sushmita. So yeah, this is a very simple and pretty good solution. So if you can see, they're just taking all possible strings and they're just reversing those and checking if they are palindromes and then incrementing the count. So if I recommend this solution as it is much simpler, but there is one more solution. However, it is based on dynamic programming. So this is not as simple as the other solution, but I'll still go ahead and explain it if it would be a nice learning curve, because you'll be learning about dynamic programming as well. So dynamic programming is something which you use the previous values to compute the future values. So let's take Fibonacci numbers. Say 1 and 1 are initial Fibonacci numbers. So you compute the next Fibonacci number by taking the previous two Fibonacci numbers. So that is 1 plus 1, which is 2 and 3 and 5 and 8 and 13. It keeps on going like that. So this here is a one-dimensional DP, as in you take the previous two values in only one dimension. So here our solution will be following two-dimensional DP. So the simple logic that we are following here is, from the start we'll be checking if the strings are palindromes, all the substrings are palindromes, and remembering the values. So we'll check if we know that the single letters are palindromes. So here we are initializing those to 0. So when ignore this column, the 0th column, when I say from 0 with the string length of 1, as in with the length of 1, from index 0 with the length of 1, that is M. So that is a palindrome. A value 1 here indicates that it is a palindrome. So likewise, so starting from 0 with a length of 2, which is MA, it is not a palindrome. That's the reason we have value 0 here. So coming here, we will be checking all the substrings here in this manner. So 0, 1, 1, 2, 2, 3, all of these are 2 length palindromes. Here all of these are 3 length palindromes, 4 length and 5 length palindromes. So it keeps on going however big your string is. So this is the actual heart of the logic that we'll be following here. So it is highly recommended that you perform a dry run, that is, you take a string on your own, you do all the stuff manually by following this code, then you'll get the logic easily. And yeah, so let's take an example here. Let's take this string here. So your I value is 1 and your j value is 3. So when you come here, str of 1 is equal to str of 3. 1 plus 3 minus 1 is 3. So yes, str of 1 is equal to str of 3. And here you're actually using DP. You're checking if the string between 1 and 3, which is D, is a palindrome or not. we know that it is a palindrome, so let's check it here. So j is 1, so j plus 1 2, so table of 2 and I is 3, so table of 2 and 1, starting from 2 with a length of 1, starting from 2 with a length of 1, which is d. It says here that it is a palindrome, so when it is a palindrome, we make table of ji as 1, which is table of 1 3 as 1, ada here, so that is a palindrome. So you make this as 1 here and increment the count. So the same logic follows for this as well. When j is 0 and I is 5, j here is 0 and str of 0 plus 5 minus 1 is 4, so str of 0 and str4 are equal. So now we need to check if this part is a palindrome. Instead of doing it again, we have done it already and we know this answer for it, so that is what we are checking here. So table of j plus 1, it is 1, and I minus 2, 5 minus 2 is 3. So let's check if table of 1 and 3 is a palindrome. Yes, it is a palindrome, so we increment the count and make this part as 1. So hope you got the solution. It's recommended that you try another example on your own. Happy coding.